out to you that we can take the magnitude of dt dt and take the definition for curvature and just solve for it. What happens if we solve for the magnitude of dt dt and the curvature? We get what? It's equal to what? It's equal to v times the curvature, right? V times kappa. Okay? So this gives us then, I'm going to solve this for dt dt. So we got dt dt is equal to the magnitude of dt dt times n, which I could have written like to start with. But then this is what? This is the curvature times v times n. Right? So I think we're done with the first equation because that is the first equation. See that? See this? This is this. So I'll record our success up here. dt is just equal to kappa Vn. That's the first of the Frenet-Serre equations. All right. Now, we also know that n dot b is equal to 0, right? There are various ways to derive the rest of the equations. I'm just going to try to get through it as fast as I can because we're almost out of time. So n dot b is 0, 0. If I differentiate this, I get m prime dot b plus n dot b prime equals to 0, differentiating, right? Product rule. But we already know, oh, wait a minute, we don't know. Rats. Well, actually, do we know any of these? What does this tell? What is b prime dot n? B prime dot n is equal to what? By definition, it's minus tau v. So b prime dot, so this says n prime dot b is equal to minus n dot b prime, but that's minus tau v by the definition of the torsion. So apparently, there's one, n prime dot b is equal to tau v. All right, so that's this one. This apparently is tau v. Let's try this same idea on the other one, right? We also know that n dot t is equal to 0, right? So that gives me n prime dot t plus n dot t prime equals to 0. So that says that, what was t prime equal to? We've got it right here. So that's equal to what? Minus n dot kappa vn, which is what? Minus kappa v n dot n. What's n dot n? N dot n is 1 because it's a unit vector. So that's minus kappa v. Hey, check it out. We just got the second equation. Okay? So dn dt is equal to, I'm supposed to have a minus. Oh, there is a minus. Minus kappa v t plus tau v b. And then let me just finish by saying that db dt, it turns out, you can show it has to be minus tau v n. So these right here are the so-called Frenet-Serre equations. Those are the Frenet-Serre equations. Now I want to use those to finish here by talking about acceleration, because it would be a shame to not talk about acceleration in this discussion, since we have everything we need to understand it. So acceleration is what? Well, velocity is what? Velocity is equal to the speed times the unit tangent. right? Differentiate that, what do you get? Acceleration is dv dt. But that is d dt of vt. And unlike the helix, generally the speed is not constant. So we have a product rule, we have to do the product rule. So what that gives us is dv dt times t plus v times dt dt. All right? Now, you could write v as equal to like you could write v as equal to ds dt. Probably Dr. Joseph will talk more about that next time. The old Newtonian notation for that is s dot, dot being a time derivative. So really what you're looking at here is dv dt is actually s double dot. So you got s double dot times t plus v. And what's dt dt? Well, we know what dt dt is. We just worked it out. It is kappa v n. In other words, we have s double dot t plus v squared over r n. That is the acceleration. The acceleration has two parts. One is tangential, one is normal. The normal part depends on the square of the speed divided by the radius of curvature. This is a general derivation. It's not just for a circle. It's for an arbitrary path that's nonstop and nonlinear. And to answer the question I posed at the start of this, two curves are congruent in the sense of high school geometry if, with respect to a choice of the arc length parameterization, you can pick a base point for both such that the arc length and the torsion functions are the same. So if they have matching arc length and torsion functions, that classifies the curves as being congruent in the sense of high school geometry, and that pretty much does it. So anyway, I could do another example, but I think Dr. Skimbourdis usually ends about now, so I'm going to end about now, since you guys are not accustomed to going full time on Tuesday, Thursday. Thanks, guys.